Today I'm going to have a look at PCB Studio and doing a bit of back and forward between Ecad and MCAD. So I'm here in Onshape at the moment. I'm starting out in an assembly that I've built, which is really just a mechanical engineer's concept about this stompbox pedal for my guitar playing enjoyment, right? So I've got a box and I've got a few components in here. Now, the box is a very common thing, right? And it's a Hammond 1590B size, normal size, right? So what I've done is I've built this, and I can just sort of show you a few key components, especially the big and bulky ones, from a mechanical engineering and mechanical layout point of view. This is kind of where I want to put things. So I've just made an assembly, with my box and with some of these other components. The first thing I'm going to do is really highlight something that's very important, which is display states. Now, display states are going to be really important for here because I've got a few different contexts that I need to keep managing and keep referring back to. So I've got a context here, which is just components on a board. I've got a context here, which is the sizing of the board itself. So that's how I'm going to start things. Now, I'm replaying some of this rather than doing it from scratch, so I might have to jump around a little bit. Right, immediately start jumping around, sorry about that. What I did to create this ICPS, or In Context Part Studio, I always name them that, is use the Create Part Studio in Context function up here in the toolbar. And the reason I created this display state is that the display state you're in when you create this context is the context of the assembly that you're going to use in there. Now, you can come back and change this later on, which is why you want these display states to be persistent. So really, all I want to do here is use the box, and I'm going to create a board which fits in the box. So that's the whole point of this In Context Part Studio of the PCB. So let me roll back now. I needed that to be rolled forward, and I'll roll back to kind of the beginning of that. So having created the assembly context, which is called PCB sizing. Now, really another important tip here is to rename context so that you remember what on earth you were doing when you come back to it the next day, like I am. I did this last night, and I'm trying to remember what I did. Good thing that I named it. So you just hit rename and put it to whatever you need. Now, there's some other contexts down here which also have been named carefully, and we'll get to them later on. So once we have a context of the assembly, we're in a regular part studio, but what it allows us to do is create features. And as soon as a feature like this plane, which is offset from a face in the assembly context, as soon as that's created, now we've got a link between, see that orange highlighted arrow, which it means that this plane refers to something which comes from the context. In context modeling is very, very powerful. I'm not going to go through the whole thing here. Suffice to say that the next feature, which is also an in context feature, again, you can see the arrow pointing, and it tells you now, I don't know, a number of releases ago we added this. It shows you which context it actually comes from. So this is the PCB sizing one, as opposed to some of these other ones, which we'll get to in a minute. So my next feature was to create an intersection between that plane and the faces on the inside of the box. Once I have that intersection, I can fill it. Right? There's many ways of actually doing this, but I'm using a curve and then filling technique to do that. All right, sorry, I'm also using a Windows machine at the moment, so everything might be a little bit backwards for my mouse. So let's just hang in there. All right, so once I've got this face, I've created it using a fill. I'm going to thicken it to create the thickness of the PCB. And what I'm also going to do is then use a move face feature to give it a little bit of allowance off the side wall, right, so that it can actually fit it in. I've just given myself 0.5 millimeter or something like that as the allowance. Very, very handy technique to do that. So this has created a part, and I'm going to rename this part and call it board. Right? I could call it PCB board or PCB board. There's a few different names that the documentation tells you are good names for this to be used in PCB Studio a bit later on. So this is all we wanted to do in this first context. If I go back to the assembly and show you, obviously there's the board in the assembly and everything is so far so good. The next thing I want to do is bring back my components. Now I've got this display state, remember, in the assembly where I had put this LED and this switch, and there's a couple of things on the inside again, these jacks and the jack for the power jack as well. So those components have just been sort of roughly placed, well, not roughly placed, but placed where I want them to be in the assembly and sort of on the board there. All right. The reason I want to do that is to go back to this display state, and let's use the components display state now. And I am going to go back to the Power Studio where I was defining this board and do some more editing. All right. So let's do that. Let's go back to the that Part Studio, and I'm going to go into the initial placements context, and you can see the stippled or the transparent sort of version of these components of the context are there for you to be able to reference when you start creating features on the board. Now the features that I want to create on the board are pretty simple ones. They're actually just sketches, and I'm going to create a sketch which is kind of roughly going to rough out where the component placement should be for these major items. Like that sketch there is for the sockets. I've got another one which is for the switch, and I've made these sketches red. Of course, you right click and say edit sketch appearance. Could be any color you like, but just the red seemed to go contrast nicely with the green board. All right, so I did that for 4 different component placements, and you can see here I've named the sketch again pretty carefully. It's got the text component placement, and then I've just given extra text, a string for whether it's the LED or the power, or the sockets and the switch. Right, so I've got 4 different sketches in here now, and just to make it a little bit more aesthetically pleasing, I've actually created some surfaces so that you can see that this has got no consequence at all for what is about to come next. This is purely for when you look at the board on its own without the context. You can see those areas, but the key bit is to make a sketch, call it component placement something something, component placement something something else. Right. And again, the documentation will tell you some of the other keywords you can be using in order for PCB Studio to correctly interpret them. And at this point, this is where we would go and we would create a PCB Studio tab, which is what I've done over here. And the PCB Studio tab's already got a couple of things in it. Again, this project was already done last night. So let's pretend that this is blank. What I would do is I would sync a Part Studio with PCB Studio. So that's this option here. What it allows me to do is pick one of the Part Studios or assemblies, and I would have chosen this in context Part Studio and said OK, and what it would do is bring in the board that's called board or PCB. That's why the naming is important. And it will also populate it with these keypad areas, which is the component placement areas. And if we look at the bill of materials of the board, it's a pretty simple one. Here we go. So there's the sockets, the switch, the power, and the LED. So these are the component placement areas which are now in the PCB object model or data model here. At this point, it is time to send that to an IDF. Right, so I'm just showing you the basic IDF data exchange format, which is common with Ecad tools like Altium, Cadence, Eagle, Ecad, all those sorts of things. So I would export this to IDF, and then the workflow picks up in that the Ecad designer would import the IDF into their environment, it might be Altium, and do some work. And this is how I did it. I created a quick project, and I created a PCB and a schematic, and I imported the IDF board. And the IDF board came in. I won't show you some of the options, And then inside my Ecad environment here, what I'm doing is I'm just starting to rough out a schematic. So I've brought in some of my favorite components. I'm typically using the manufacturer part search so that I get components that come in that I know are available, and I know that have footprints and symbols that I need later on. Anyway, so if you can see this part here, looking on its properties, you'll see that it is a switch, and it actually has 2D footprint and a 3D model like this available to it. Incredibly useful thing and powerful thing in Altium. Once I have done that, then I can go back to the PCB where I've really laid this out properly and put the components in place properly. I can actually have a look at a 3D version of what we've got here. There we go. Oops, sorry, mouse direction was wrong. That is, like a really early placement for these major sockets, switches, and so on and so forth. If we had more time, I would show you routing the rest of the circuit, which I would have put in the schematic first, but let's not do that today. At this point, I would then export this again to an IDF format so that we can close the loop back to the Onshape environment. What we would do then is, instead of sending this, we would import an IDF from the Ecad environment. That's this other one here. And if I do that, I'll show you the result of that. I would just bring in the EMN and EMP files, or the IDF files, and this is what's created in PCB Studio. You see, it is rather familiar indeed. If we have a look at the bill of materials, you'll see that there's something I forgot to put a designator on, or it's unfinished. But I've got the part names and part numbers, which are exactly the same as the part names and part numbers from Altium. The other important thing you'll see here is that these have come up in really nice 3D models. That is because I already had a library part in my Onshape environment which maps to this particular part. If you click on any one of these parts here and look at the details of them using the properties panel here, you'll see that there's three options you've got for how you represent them in PCB Studio. I.e. none, like there's no representation, you'll see the blank. You can use the Ecad data, which typically is a really simplistic kind of cube, or a very flat cube in some cases. Or you can use a custom part, which is actually from your own Onshape PCB component library. And that's what I've done here. If you need to make adjustments in rotation and translation with respect to the footprint that the Ecad is expecting, then you can do that here as well. But otherwise, it will come in exactly as you would expect. You see the footprint lines up with the holes, all very good. Right, at this point, we could create an assembly. So this isn't an assembly in Onshape yet. This is a PCB Studio assembly, or PCB Studio model. What we still need to do, if we want to go further, is to create an assembly from this Ecad data. And you press this button, probably 30 seconds later, it actually constructs this model, which now you'll see is a much more familiar environment. This is an assembly environment. We've got these same looking parts. They look a little bit different. They are actually coming in from my library. And you can see that this switch was actually a composite part that I'd created earlier, but it's in my library, and so on and so forth. So I've got fully populated assembly here, which now I can use in the normal way inside Onshape. So I've created an updated top-level assembly, and I'll show that why in a minute. So these components you're looking at now are the ones that we didn't start with. I used the conceptual ones to start with. These are now the ones that are actually placed exactly as per the Altium Designer's wishes. But we're back in the MCAD land now, so it's time to do a little bit of MCAD, or mechanical CAD work. What I'm going to do is, again, refer to a very important context, and I'm going to create a context, or I'm going to use a context which is going to allow me to do some edits to the box for drilling the box. Right. So I've got this display state already saved, and that is cutouts, and it's also doing, it's just taking out the 4 screws and the lid of the box. Everything else is kept in here for the context that I need. Obviously I need the switch, I need the LED. I actually don't need the board, to be honest, but I've left it there just for fun. Now that I've got this context, I can edit this box. So what I did is I click the box. I'm going to create some edits on it, i.e. cut some holes in it, and I'm going to edit that in this context called the cutouts. So again, this is really why it's very important to name the context very, very carefully indeed, so that you don't just accidentally use the one context in the wrong context. All right. So another tip, lots of tips here, mainly for in-context modeling, because I think that there's lots of interesting things. With the visibility of this, it is really good idea to show all of the hidden edges, make them visible, so that you can actually see through the translucent model of the. You can show the edges of the context model as well. Makes it much easier for this next step. And this next step is a really simple one. I'm actually just going to show that plane there, make it a little bit smaller, and start doing some sketches. Now this first sketch that I'm going to make is, let's make that red actually. Let's move that. Let's make this, blue should show up nicely. Okay, so this first sketch, which is on the face of the box. So by doing that, we're actually going to then create some circles, or I'm going to create a sketch, which is a couple of circles which are concentric with the contextual information, like this switch. There's a few good references we could use around here, or anything that's a stable circular or edge reference that we're going to use. This is a standard size. If we have a look in here, most of these cutouts are 13 millimeters for these switches. You can get that from the data sheet. And for this bezel, it's an 8 millimeter diameter hole for these LED and bezel type devices, again from the data sheet. So I just put that in there and very simply do an extrude from that sketch to cut through the box perfectly. So, and of course, while you're doing this, is that because if the assembly changes and therefore the context changes, then these sketches and therefore extruded cuts will also be updated as well. That's the power and beauty of in-context modeling. I do the same thing for the side holes here. So there's a couple of sketches. Again, I'll make those blue so that they show up. They're the holes that are going to be used to facilitate the jacks and the socket for the power connector on the other side. Again, a couple of extrudes will take care of the business there. They are the only external holes that we need to make in this case. So you can turn off the context if you like and just see the final edits on that box. There we go. Turn that back on again. Once we're happy with that, we just go back to the assembly and it'll take you back to that contextual assembly. Now there's a couple of little screws on the outside that are missing, but that's just me being a little bit lazy. So a washer, insulating washer, and a screw that goes on here as well. But largely at this point we're kind of finished because we have, let's go back to the display state that has everything. We're in our new top level assembly here. This top level assembly takes into account the positioning and sizing of all of these mechanical bits that we have sort of agreed or collaborated with our Altium Designer user friends. And at this point, we could then just keep the cycle going. We could wait for updates, perhaps for a fully populated board. If things need to change, we need to change the socket position. There's going to be an iteration cycle there as we change those socket positions and update the cutouts. But I think you can pretty much imagine that this is the process and the workflow that we would go through now. This is a really simple case. Obviously, creating these boxes from scratch is a different use case. This just happens to be an extremely industry standard shaped enclosure, and so this type of introductory workflow might be something that people can pretty easily get their heads around.